All right, today we're going to be talking about the binomial theorem. The binomial theorem is one of those things, it looks a lot worse than it is. You are, again, having homework due on Wednesday. And I was going to tell you something else, but you are getting Desmos for this.
Oh my God.
Are we so excited? We're getting Desmos for this assessment because, yeah, we just are. So just letting you know, you will have Desmos available to you. I don't know how much help it'll be, but it will be. I am going to be using Desmos today to show you some tips and tricks. Okay? So the binomial theorem is a formula for the expansion of x plus a to the n for any positive integer n. Now, you learned in middle school or algebra 1 that if you took a binomial, if you took a binomial, let me insert a revealer. So y'all, anything to the 0 power is 1. That's why that equals 1. Do y'all agree with that? Yeah. Okay, then a plus b to the first power is just a plus b. Cool. And you learned in algebra 1, a plus b squared, you have to do what? FOIL that out, and then you get a squared plus 2ab plus b squared, right? I think in algebra 2 y'all learned about cubic. Did y'all learn about cubic in algebra 2? Yes, no, maybe so. Some of you like no. Well, in here I am going to teach you how to do any binomial a plus b to any power n. Now before we go and do that, I want you to look at these different ones. What do we notice about these? N is a number. What do we notice about it? Say that again. What do you mean it ends with the same number it starts with? Because you're right, but what do you mean? So if it's a plus b to the power of 5, it starts with a to the power of 5 and ends with b to the power of 5. Do y'all agree with that? Same thing with the fourth, the fourth, the fourth. It does that for all of them. Very good. What else? What do you mean? Oh, look, a to the power of 5, and then what's the next one? A to the fourth, a to the 3, 2. Do y'all agree that's technically 1? And then what happens here? It's 0. It goes away. Now look at what happens to the b's. While a is going down, what's happening to my b? There's no b there. Do y'all agree? And then what happens here? B to the 1, b cubed, b to the fourth. So while one is going down, the other one is going up. Very good observations. And do y'all notice that's happening with all of these here? 4, 3, 2, 1, 0, and then 0, 1, 2. That happens with all of them. That's a very good observation. Anything else? Okay, so I get what you're saying because you're like, oh, 5 times 2 is 10, but does that necessarily work right here? No. But what do you notice? What? There's number. There's a number out front. What's the number in front of all of them in the beginning? 1. Do y'all agree there's a 1 in front of all of them in the beginning? And at the end, what's the number with all of them? So now that y'all are looking at coefficients, I'm going to show you this as just coefficients. What do you notice here? 2, 3, 4, 5. So right here, do y'all agree it would start with, in my 6th row, what would it start with? A 1. And then what's the next number going to be? 6. What's the next number going to be? Okay, if you don't know, I'm going to tell it to you. What if I said it was 15? Could anybody guess the number after that? 20. Where are you getting 20 from? Okay, 20's right. And then what's the next number? 15 again. Where are we getting? And then the next number? 6. And then the next number? Where did I get those numbers from? I can just add the 2 top numbers above it, and it gets me the next number. Do y'all agree with that? What's 1 plus 3? What's 3 plus 3? Bam. What is 1 plus 4? What's 4 plus 6?
I like this math.
Right? We like adding. So that's going to be one of your questions on your assessment is, can you create Pascal's triangle? Now, something else I want you to notice is, what about the number of numbers in each row? If my exponent is 0, how many numbers are in this row? When my exponent is 1, how many numbers are in here? 2. So that's something else I want you to pay attention to. If I were to ask you for the n to the 21, n equals 21, how many numbers should you see in that row? Are we good with that? All right, cool. So this right here is actually called Pascal's triangle. Pascal is a French mathematician, and what he noticed is what we just saw. When you are taking binomials and you're making the exponent bigger and bigger and bigger, you can just take the number in front of it or above it and add them together. So how do you figure that out? You don't have any technology and you sit there and do equations all the time. So what he did is, you know how you FOIL with 2 parentheses? He sat there and FOILed with 6 parentheses and did it out. And did that. And then he did 7 parentheses and did it out. And then that's how he recognized the pattern. Now, am I going to expect you to FOIL 7 different times to find x plus 2 to the 7th? No. But today I am going to show you how to do it, maybe a little complicated. And I will say, today is going to be one of those days you're going to be like, whoa, okay, that makes sense, but whoa. Tomorrow, you're going to be like, okay, after doing this 4 or 5 times, you're doing the same thing over and over and over, and it gets easier. So again, today can look a little intimidating and be that's a little much. Tomorrow will get easier. So what I would like you to do on our notes for the binomial theorem, I would like you to write Pascal's triangle so you have it somewhere. So on page, what page are we on? 38? Okay, for 38, please write this down. The binomial theorem is, what did I say it was? X plus a to the n, where n is a positive integer. And so Pascal's triangle is, if I have n equals 0, what is my triangle? 1. N equals 1, and these are just the coefficients. What are my coefficients going to be? 1 and 1. If n equals 2, 1, 2, 1. N equals 3, 1, 3, 3, 1. I want you to go all the way to n equals 6. What questions do I have? Can I move on? Do we have that all written down? I see a couple people writing, so I'll wait a second. Now, Pascal's triangle, it's actually a bunch of different combinations. What is a combination? Do y'all remember? My seniors, or not my seniors, Khaled, when you were in geometry, was that the year of online? No. Right, but was that the year that we were like half people were online, half people were, or was that enough? Okay, but you were never at home during geometry. Were you at home during algebra? No. You never went home. Okay, were people at home during algebra or geometry? Which one? You don't remember? What grade were you? Okay, what grade were y'all in when it was like half online? Not the grade COVID happened.
8.
Okay, so you were in algebra. Okay, so you should have. I don't know about seniors. My juniors and previous, y'all should have learned probability at the end of geometry. Okay, you did. Okay, I was gonna say I know during COVID didn't, and I know last year they didn't, just because of the tornado, El Derecho. But my juniors, I do believe y'all learned probability. When you learned probability, you learned about factorials. Do y'all remember what factorials are? The exclamation point. Do y'all remember what the exclamation point in math means? Everything behind it multiplied together, right? Right? 5 factorials, 5 times 4 times 3 times 2 times 1. Okay? You also learned about combinations and permutations. So a combination is whenever you are trying to take a smaller amount out of a pool, like out of a group of things, take a smaller amount and order does not matter. Permutation, order matters. So for instance, track season just wrapped up or is wrapping up. And in track season, let's say you had 30 people go for an event for the 100 meter. 30 people were competing, and the first, second, and third place, I want to know who they are. What are the combinations of people that competed that could make the permutations of people that compete could make first, second, third? That is permutations. Order matters. Who makes first, who makes second, who makes third. However, districts just happened, and I'm making things up right now. Let's say in districts, 20 people made it to districts, and I am taking the top 3 to regionals. Do I care who made first, second, and third? No, all I want is the top 3 people get to go. That's a combination. The order does not matter. Doesn't matter who made first, second, and third. I just want the top 3. All right? So combination order doesn't matter. Permutation order does. Here's another example I used last period. You have, let's pretend, 4 options to take for math next year. Stats, college algebra, Calc AB, Calc BC. Let's say you are determined to take 2 of them. What are the different combinations you could have of math classes at Jersey Village? You could have stats and AB. You could have stats and BC. You could have stats and college algebra. You could have, so that's what this is figuring out, how many different combinations there are. All right, so what we're going to write down is for combinations, order does not matter. And the way that we write a combination, or the way that you're going to see us write a combination, is like this. You're going to see it written like this. So it's going to be N choose J, or N taken J at a time. Your N is going to be your bigger number. N always has to be greater than or equal to J. The formula for N choose J is N factorial over J factorial, and then subtract them factorial. And again, off to the side, what is a factorial? What's 5 factorial? Multiplying that number, decreasing. So what if I did 3 choose 1? What am I going to plug in? Three factorial over what's my J? Over 1 factorial, and then 3 minus 1. Now I'm plugging this in for notes. Am I okay with you going straight to this? Absolutely. And actually on your homework that you're going to do today, it's going to tell you, write an equivalent expression. This is what I want your answer to look like. But if I tell you to evaluate that expression, 3 factorial, do y'all agree, is 3 times 2 times 1? Right? 1 factorial is just 1. What's 2 factorial? 2 times 1. And what can I do here? I can cancel, and what's left? What's 3 over 1? 3. So this is my answer. I've just evaluated that combination. Does that make sense? By the way, anytime you have a number choosing 1, it's always going to be that number. Right? If I have 10, choose 1, how many different combinations could I have? 10. All right, here's what the example I just gave you. What if I had 4 math classes to choose from and I wanted to choose 2? How many different combinations are there of this? I'm going to do 4 factorial over 2 factorial and then subtract them. This is an equivalent expression. Now I'm going to evaluate. Do y'all agree those cancel? And what's left up top? How much? No. Oh, that's the answer. How much left up top? 12. How much is on bottom? And 12 divided by 2 is 6. So there are 6 different combinations of classes that you, math classes, where you would choose to. Does that make sense? Now, what if I gave you 20, choose 4? Like in track or swim or whatever. Are you going to want to sit here and do 20 times 19 times 18 times, doesn't that get big real quick? You can plug this in and say 20 factorial over 4 factorial, 20 minus 4. However, I am not going to expect you to do it like we did over here. In fact, didn't I already tell you I'm giving you Desmos? I'll show you this in just a second. I want everybody to look up in Desmos. If you hit the functions button, everybody look up. Scroll all the way down. The very last button is NCR. N is just your N, so I'm going to type in 20, comma, R is like your J. What's my J here? 4. And it gives us the answer. So this right here, what I want you to write here is 20C4, and it was 4,845. I don't know if anybody uses TIs anymore. Do y'all use TIs still? Anybody at home? Okay, some people do. So I did want to show you that TI also has this. If you're looking right here, you just hit math under the green button, arrow over to probability, and do you see it? It's a little bit different, number 3, in that you would do 20 right there and 4 right there. And then hit enter and you get the same thing. Okay? But either way, can you just use your calculator? Do that. Alright? Unless I'm asking for the expression, like on your homework, it says write the expression, then I want this. But if it says evaluate, give me an answer, look, it tells you you can use that key. Okay? All right, that is combinations. Why are we talking about combinations? Well, guess what? Pascal's triangle is just one big combination, or a bunch of big combinations together. All right, it is taking the combinations. So although it added them together from above, what it's actually taking is these combinations of you have 2 options, pick 0, 2 options, pick 1, 2 options, pick 2. I don't need you to know this. What do I need you to know? If you know that, you're good. I just wanted you to know how these were connected. Okay? So now that's going to bring us to the binomial theorem. If you have a bunch of room left on the page, you can stay there. I'm going to move over to the back just because I write big and spacious. But now we're going to actually talk about the formula for the binomial theorem. Because although I gave you Pascal's triangle, when you have x plus a to the n, that is going to equal, this right here. It is going to equal the summation of your lower bound of 0 to n of the combination of n choose j of x to the n minus j, a to the j. Now, I told y'all it looks intimidating. It looks crazy. As soon as we do multiples, you're going to be like, oh, you're just doing the same thing over and over. We already noticed earlier a bunch of patterns. Those patterns are still relevant. So what I need you to know is a couple things. You're always going to start with n, choose 0, of x to the n. And a is going to always start at what? The second variable or second term was always what? Do y'all remember when we were doing that other one? Y'all notice patterns? One of them went counting down, the other one counted up. So this one should start at a to the 0. Plus, and then you're going to do n to the first, or n choose 1. X to the, what am I going to do to this exponent now? Go down, n minus 1. I don't know what you said. What am I going to do to the next one? I'm going to go to the first term. So whatever I'm choosing here, that should be the exponent here. Does that make sense? Plus n choose 2. It'll be the x to the n minus 2, a to the 2. And then we're just going to keep going all the way until you get to n choose n. At this point, what should x be? Write it down. 0. And what should a be? N. Remember how one of them start with 0, one of them started at n, went to 0, one of them started at 0, went to n. Again, I know a lot of you are looking at this like a big nope. We'll get there. Don't worry. I'm going to get us there, okay? So we're going to do 2 examples. What example are we on? 4. What is x plus 2 to the 5th power? What do I know looking at this? N is 5. Cool. And if n is 5, what else do I know about this binomial? How many spaces should I have? How many terms should I have? 6. So let's do 1 and do an equal sign, please. 2, 3, 4, 5. I should have 6 terms. I like to do this part by part. You don't have to. You can do each term at a time. I like to do the parts at a time. So watch. I'm going to start off. My combination is going to be 5, choose 0. Then I'm going to do 5, 1. I'm going to do all the combinations first. 5, 2. 5, 3. 5, 4. And 5, 5. So I did all the combinations. Now I'm going to do my first term. What's my first term in the binomial? X. And what should X start off with? X to the 5th. Then X to the 4th. X to the 3rd. X to the 1st. And X to the 0. And then what is the second term in this binomial? Jonas, you with me? What's my second term in the binomial? A, but in this case, what's A? 2. And so what am I going to do to start off with 2? 2 to the 0. And then 2 to the 1st. And then, do y'all see what I meant by I like to do this by parts? Now, if you want to do the full blank together, you could. I just do it like this. All right, how do I figure out all these parentheses? Do it. Y'all, 2 things you could do. Number 1, could you put this in the calculator? Could I say, hey, what's 5, 0? What's 5, 1, 2, 3, 4, and 5, 5? Or, what else could I do? Can't you go to Pascal's triangle and see what all those combinations are? It's the same thing. Either one works. So, you can either do Pascal's triangle or you can just put them in the calculator and figure out what they are. But do y'all agree this was 1, 5, 10, 10, 5, and 1? Yeah. So if you wanted to do Pascal's triangle instead of that, that's fine. Alright, so 1, I have x to the 5th. What's 2 to the 0 power? 1. Good. Then I have 5, x to the 4th. What's 2 to the 1st power? I'm just simplifying these out now. Then I have 10, x to the 3rd. What's 2 squared? Then I have 10 again, x squared. What's 2 to the 3rd? Good. Then I have 5 and x. What's 2 to the 4th? Anybody? 16. And then I have 1. X to the 0 is just, thank you. You can throw that away. And then 2 to the 5th is 32. Yeah. And now you're just going to simplify out each term. What is 1 times x to the 5th times 1? Do y'all agree that's just x to the 5th? What is 5 times x to the 4th times 2? 10x to the 4th. What is 10x to the 3rd times 4? (10x squared times 8). This is this class every day. Look at Kinley.
I think I get it. Maybe just a little bit.
5x to the 6x times 16. You have a question?
I was already going to get past.
Yes. Yep. And then 1 times 1 times 32. And this right here is my answer. See you tomorrow. Any questions? What questions do I have? Okay, not that this was super easy, but was it super difficult? Once you catch on to the pattern, does this make sense? All right, I will say be careful with this next one, example 5. It does create a little bit more of a challenge if I have a coefficient in front. So let's do 2y minus 3 to the 4th. What do we know? N equals 4, which tells us what? 5 blanks. And do you agree I could start off right off the bat and do 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4? But some of y'all might not like to do that. What would you rather do? If you did Pascal's triangle, what could you write instead? 1, 4, 6, 4. So could you do that? Sure. 1, 4, 6, 4, 4. All right, here's where you got to be careful. What's my first term in the binomial? 2y. 2y are both going to have to go to the 4th. And sometimes people forget that. They just do 2y to the 4th. No. It's parentheses 2y to the 4th. Parentheses 2y to the 3rd. And then my second term, what do we start that off at? Negative 3 to the 0. Negative 3 to the 1. Negative 3 squared. What is 2y to the 4th? It is 16y to the 4th. Be careful that you don't write 2y to the 4th, or you don't write 8y to the 4th. It's 16y to the 4th, because you have to do 2 to the 4th. And then what's 3 to the 0 power? Negative 3 to the 0 power as well. I'm going to bring down that 4. What's 2y to the 3rd? 8y to the 3rd times negative 3. 2y squared. And what's negative 3 squared? 9. It's just 2y. What's negative 3 to the 3rd? Huh? Negative 27. And then 2y to the 0 power is 1. And then what's negative 3 to the 4th power? 81. And again, we love this because we are going to get Desmos. So 2y minus 3 to the 4th power is, now we're just going to simplify. What's that first term going to be? I know Lynn's with me, but what about everybody else? Kinley's kind of with me, yeah, I agree. What's the first term going to be? 16y to the 4th. What is 4 times 8y to the 3rd times negative 3? I'm going to break out Desmos at this point. 4 times 8 times negative 3 is negative 96 y to the 3rd. And what is 6 times 4 times 9? Not doing that in my head today either. Whoa, that was supposed to be a parenthesis. 216, and that's positive. Y squared plus, what is 4 times 2 times negative 27? So that's 8 times negative 27 is negative 216. I already wrote that plus. Let me erase that. Y. And then 1 times 1 times 81 is, and this right here is your binomial. Not your binomial. Is the binomial theorem worked out. What questions do I have? Do you agree after doing this multiple times, y'all will be like, it's just repetitive. All it is once you get the steps down, you're just multiplying it out. Yep, just a bunch of numbers, and you get Desmos. All right, what I'm going to have you do right now is, I already told you that on Wednesday you have homework due for a grade. I'm going to pass this out. You have 9 minutes. It's going to take you to, I want you to do 2, 4, and 6, 8. This is part of your worksheet. Your homework is this worksheet plus bookwork. So again, you can do the front evens right here, right now, before you leave, and still have 5 minutes to just chill on your phone. So do 2, 4, 6, 8, get Desmos out. This is part of the homework. The homework is all of the evens. I just want you to do the front right now. It's going to take at least 2 minutes. Number 2 and 4 you can do in less than 30 seconds. 6 and 8 might take a little effort, but you got to look at your notes and you should be good. By the way, I think I said this earlier, but look at 5 and 7, the answers. That's what your answers to 6 and 8 should look like. I want you the expression, I don't want the actual number. For number 6 and 8, I want the expression, I don't want the actual number. So 6 and 8, you can't use Desmos. All right, like, subscribe, comment.